YouTube channel. In this Verilog series, we are covering serial input and parallel output shift register. A shift register is a sequential logic circuit which is used for storage purpose or for transfer of binary data. The serial input and parallel output shift register is similar to the serial input and serial output shift register. Here, in serial input and parallel output shift register, the data is passed serially to the flip-flops and outputs are fetched in a parallel manner. The data is passed bit by bit in the register and the output remains disabled until the data is not passed to the data input. When the data is passed to the register, the outputs are enabled and the flip-flops contain their values. In this block diagram, we can see that it consists of 4 flip-flops. That means it can store 4 bits. That means it is a 4-bit serial input and parallel output shift register. It contains clock and clear signal. Whenever we want to reset all the flip-flops to 0, then we use clear signal. In the serial input and parallel output shift register, the input of the second flip-flop is the output of the first flip-flop, and the input of the third flip-flop is the output of the second flip-flop, and it goes so on. That means here the shift register is a synchronous one. The parallel outputs here, it is used for communication purpose. Okay, let us discuss with an example. We are taking an example as 1011 as input. By using this truth table, we can clearly understand the process, how it transfers bit one by one. For the first clock pulse, QA consists of 1, remaining all 0. For the second, QB consists 1 and QA contains 1, remaining 0. For the third clock cycle, QC 1, QB 0 and QA 1. That means it transfers the data to the left side or right side by 1. Here in this truth table, we are shifting to the right. For the fourth clock cycle, we will get 1 0 1 1. By this timing waveform, we can clearly see how the bits are transferred one by one serially, and we get output as parallel manner. Okay. Okay, now let us see the Verilog code of SIPO shift register. Create a project. Name as SIPO shift register. Yeah. Browse. So I have already written the code. I am just fetching my code, adding my files. First I am compiling. So both are successfully completed. So this is the RTL code of serial input and parallel output shift register. Module, and within the parenthesis we are having input, clock, D, in, clear. These are the inputs. So this is declared using input keyword. Diode is the output and it is declared using output keyword, and it is also declared using rich data type to store the output. Using this, additionally we are using temporary register and it is declared using rich data type. Here we are writing serial input and parallel output shift register in behavioral mode. So always at the rate passage of clock, at every passage of clock the data is shifted either left or right side. Within the beginning block we are writing our logic. Whenever the clear is low, then all the flip-flops are filled with 0, or else the logic should be happen. So this is the logic. So in temporary register we are storing our shifted data. So by one time it has to shift by right and it has to store in diode. At last final diode, it contains of 4 bits. One is D and another 3 bits are stored in temporary register and then module. Now let us see the test bench of this SIPO shift register. This is the test bench code. Module name. Inputs are declared using rich data type and outputs are declared using wide data type. Here we are instantiating our RTL SIPO shift register in this test bench, and within the beginning block we are giving our stimulus inputs. So first clear we are giving 0 and then 1 and again 0, and here we are giving our data input 1. For every 10 nanoseconds we are interchanging our input. That means 1 0 1 0 like that. And by this initial beginning block we are writing $monitor and the input and the data output. That means here we are displaying our outputs in transcript and then end module. So let us simulate our code. Take test bench file, click on OK. Add wave. Okay, now let us run. Zoom. So here we can observe the waveform of serial input and parallel output shift register. Okay, done.